Okay, so on this one, I'm going to again put in the wall of separation, separating the left side from the right side so we can see those. Okay. And now, what's the first thing we do? We distribute through the parentheses, right? Whenever we have parentheses. So we're going to get 6 minus 7x. Now, careful, here's a mistake I often see students make. Minus 21. That's not right. Why not? You think, well, 7 times -3 is -21. It's not 7, it's -7. Oh, by the way, here's another mistake. Sometimes people go, oh, I'm going to just go 6 minus 7 and just make that -1. Oh, no, we can't subtract those, right? We got to start with the parentheses. I think you know that probably. Anyway, back to the -7 thing. Remember, this is a -7. That negative really belongs to the 7. That's his baby. Remember me saying that analogy? Whenever you have a sign in front of a number or a letter, that's their baby, which means you take your baby with you wherever you go. So that minus has to go with, so what? Well, -7 times x is -7x, and -7 times -3, two negatives, multiply to be positive. So that should actually be positive 21, right? Does everybody see that? Remember, two negatives multiply or divide to equal positive, don't they? You with me? Two negatives multiply or divide. Now, they add or subtract is a different story. Two negatives can make a negative when adding, subtracting. But I'm not adding, subtracting here. I'm multiplying. So when you multiply or divide, two negatives must make a positive. And that's what just happened. Negative times negative made a positive. Everybody seeing that? Okay, easy mistake to make. Here, bunk and bunk. So 1x and 1 times -1 is negative. You get there? Okay, and now these guys are going to combine because they're just plain numbers. You might be a little confusing because they're not next to each other, but it doesn't matter. Numbers combine with numbers even when they're not next to each other. So that's going to be -7x plus 27. They'll make 27. 6 and 21 is 27. This is x minus 1. And by the way, if you're disturbed about that, if you think, well, Mr. Should I put the 27 first and then the minus for next? That's fine. Remember, order does not matter. All that matters, you can put it any order you want. You just got to be careful to have the signs in front correct, and then you're good. Order doesn't matter. Signs in front matter. Order doesn't matter. Signs in front matter. So this would be fine because it's the same signs in front. There's nothing in front of the 27, which makes it positive. There's a negative in front of the 7x, so that's good too. Either way, doesn't matter. All right, now back to business here. Now notice we have x on opposite sides, don't we? Now you know what to do about that. We've done it a few times now. So x on opposite sides. What do we do about that? We do the opposite of either one. But careful to do the same to both sides, right? So do the opposite of either one. So you might say, okay, I'm gonna do the opposite of this. I'm gonna do the opposite of this 7x. I'm gonna go plus 7x. Fine. Whatever you do to one side, you gotta do the same thing to the other, right? That'll work fine. Now I could have said, no, I'm gonna get rid of this x, I'm gonna go minus x. Fine, that'll work fine too. That'll cancel this guy out. It doesn't matter. Just get rid of one of them. So when you have x on opposite sides, it doesn't matter which one you get rid of. Just get rid of one of them. It doesn't really matter which one. Bigger one, the smaller one, whatever. Just get rid of one of them by doing the opposite. But of course, whatever you do, you have to do it the same thing to both sides. We've always got to follow that rule. When we have an equation, when we have an equal sign, we have the same thing on the left side and the right side. We've always got to make sure we're doing the same thing to the left and the right to keep the balance. All right, so I'm getting rid of this one. I could have got the other one. It doesn't matter. All right, bring down the 27. Now, what do these two make now? Well, what's in front of that x is an invisible understood 1, right? When there's nothing in front of x, it means 1x. 1x and 7x is 8x, and then bring down the -1. All right, now, at this point, what are we going to do? Well, at this point, x is yelling out, I want to be alone. So how do we get x alone? That's the name of the game. So we want x all by itself, right? X is right here saying, I want to be alone, which means get rid of this -1, get rid of this 8 so I can be alone. So how do we do that? So we are going to, remember, you save the number that's right next to x for the last step, because that's times the x, it's right next to x, and we will get rid of it by divide. All right, so let's add 1 to both sides. Boom, boom. 8x is 28. And then like I was just saying, the last step is to divide. Boom, boom. All right, now 28 over 8, write it over here, that needs to be reduced, doesn't it? Right, just divide top and bottom by 4, I think. And that'll equal 7 halves. There we go. So you got to reduce that fraction at the very end. All right, so the key step there, remember up here to being negative times negative made positive. Remember to take that -7 when you distribute through. The negative goes with the 7 wherever he may go. And two negatives multiply to be positive. And I combine those numbers, and then x is on opposite sides. Just get rid of one of them. It doesn't matter which one. Do the opposite of one of them and do that same thing to both sides. And then last step is divide, reduce that fraction. There we go.